Afternoon to everyone. I hope everyone is doing well. Well, today we are continuing with our data analysis in Python, understanding structured, less unstructured data. And before we even analyze data, we first need to understand what type of data we are working with. Structured data is usually organized in a clear format, rows and columns like an Excel spreadsheet or data tables. An example would be the data we will work with today, which is our student performance vectors. This is our data, quite structured, columns, everything clear. It has about 6,000 plus records. And with unstructured data, it's a bit different. It does not follow a fixed format. It can be research notes, emails, PDFs, posts, paragraphs, text. And an example of that is what you are seeing on the screen right now. Basically, this is student research notes, and you can see how it's structured, its sentences, which has data in it, but it's pretty difficult to work with. You know, this one's the first line. Let's just read that. The learner had 7 hours of sleep, participated in activities, no, and had medium teacher support. Final exam 67. I mean, the data we can collect here: 7 hours of sleep, participates in activities, medium teacher support, and the final score 67. But imagine if you have to do that for all these different sentences and they structured so differently. When are you gonna end? So let's start off with that, just so we do not stay here for hours. I have my code on my notes, and I will be taking the blocks of code. Let's start off with the unstructured file. So basically, the code that you see here takes the unstructured text data from the Excel file and converts it into a structured table that can be analyzed. So basically, it uses pandas. Pandas is a Python library, then reads each note one by one and uses regular expressions, which is research in Python. It's called research, but you have to import it here as re or re. So it identifies the patterns in the text, such as the study hours, the exam scores, the motivation level, the gender, and other details. And whenever a value is found, it is stored in what we call a dictionary, and it is recorded. So each completed record is then added to a list, which is later converted to organized data. And yeah, that allows us to have an organized data set, and it also exports it into another Excel sheet. So the overall logic of the program is just to transform the messy human readable text into organized things or organized data that machine can read, because humans can easily read unstructured data, but computers struggle because the information is mixed together in sentences rather than neatly separated into columns or commas. So I will quickly run this code. This is the path to where my file is, which is this file over here. I'll quickly run this code, and oh, I get an error. I wonder why. I'll quickly just check my path. Unstructured research data, unstructured research data. Okay. So basically the error says permission denied, and the reason for that is because our file is open. our code cannot manipulate our files when they are open. So close that and rerun the code. There we go. Structured data set recreated successfully. Let's open up that new file it created for us, which is this one. And now we can see it's a bit more organized. It has collected the data it could. As you can see from the paragraphs we had sleep hours, we had exam score, we have exam score, sleep hours, gender, family income, school type. So basically, this is the data it has collected from that unstructured data or those research notes paragraphs. And it's not really great because we do have some blanks because not you see the data is not consistent, so it makes it hard to work with, analyze, but at least it gives us something which we can work with. You can work with it. It's not the best of data, but it is something. So let us jump to our structured data, which is our student performance factors. And we will do some basic analysis with this data. I will quickly go back to Python, open up an empty Py file. And before we analyze the data, we first need to load it into the whole environment and inspect it. So we use libraries called pandas. Pandas are designed for working with tables and data sets. So once a data set is loaded, Python stores it in like the memory, and we can inspect it, manipulate it, and analyze it, all those type of things. So I will just take the first block of code from my clipboard, paste it over here. We've imported our library. What we do now is we create a variable for our data set. The name of our data set here is student performance factors. So you need to make sure that matches student performance factors. And that's our data set. And now let's show the first few rows. Me running this. All right, no such file in directory. So basically what this error is telling me is there's no file in the default directory of PyCharm. So what I need to do is I need to copy the correct path of where my file actually is. So you can just copy the path from your folder, paste it here. Don't forget to add R for read access. So it allows Python to read. So if I run this again, we still get the error permission denied. Reason is because our file is open. So we close our file and this time it works. Perfect, great. So we see the first few columns in our file. We see that there's 5 times 20 columns, and the process finished with exit code 0, meaning no errors. This dot means there's other columns in between. This basically tells us that our data is ready, it's loaded, it works, it displays. So what we want to do now is we want to understand the data set. Basically, what type of columns exist, what type of information is stored. Are they values that are numerical or text-based? Are they missing values? We can do that with 2 lines of code, 1 line of code for each. For example, I'll just take the block of code from my clipboard, put it here. This is going to show us column names. This is going to show us the dataset information. So let me run this file. What I have now is I have my columns here, and all of them here are my column names. And as you can see, we have 19 columns, which is quite a lot. 19 columns of 6,000 plus records each. Null count, are the columns empty? No, not now. So you can see all our columns are not now. This is a pretty interesting one because this tells us if the data is a string. Str means string, meaning it's a word, or it could be sentences, or it's a float. So a float, it's numbers with decimals. If it was int, for example, int 64, 32, it's still numbers, but whole numbers. So when you see, for yeah, here we go, int 64, meaning it's a whole number. String, it's a word. Float, decimals. And yeah, basically it gives us, this information, and now we know or we understand what data we actually have. What we want to do now is we want to extract useful information. In most projects, not every column in the data set is relevant to the questions we're trying to answer. So if we want, for example, to study student performance in this case, we may only focus on the let's say, sleep hours or hours studied, attendance, motivation level, exam score. So those four categories, if we want to study student performance. So our block of code will come through now, and it shows us exactly what columns we want to work with. So our variable here is called important data. And basically, this is the important data we want to work with for our study. And I will just run the code. So basically, like printing important data means display important data. And as we can see here, we have our hours studied, motivational, or our attendance, our motivational level, our score. So basically, only the important data is being displayed. So this is the data I want to work with. What I'm going to do now is I want to organize the data. So we can organize and summarize the data into meaningful tables. We can extract, some important information like which motivation groups performs best, or which students have the highest attendance, or which categories, show lower scores, for example. So I would take the block of code and I have my variable in summary. In my data set, I want to group motivational level and exam score. So I want to see basically, I want to see average exam score by motivational level. So I'm going to print my summary and run this code again. And down here, you can see our average exam score by motivational level. So for high motivational level, we have 67, low motivational level, we have 66, medium 67. We can see that, and that was done by grouping two columns or two categories. Basically, from this important information that we have up here, what we can do now is we can now move from data organization into more of like insight generation. So at this point, we can begin with basic analysis steps, for example, calculating average, highest score, lowest score, etc. And we can do that with just a few lines of code. We can just print the highest score, the lowest score, and the average. Python has this functions built in. So you just call max, min, and mean for average. So me running this, it's gonna display the highest score in the data set, which is 101, the lowest score, which is 55, and the average exam score, which is 67. Basically, these scores here are the exam scores.
And 101 seems very odd. We can just verify in our data set if 101 actually exists. I mean, I trust my code, but like, okay, so this is a function I actually ran earlier on. And as you can see, I called a function max from T1, which is at the top of the table, the very first value in our exam score T1, or rather T2, until the last column, which is 6608. And as you can see, the highest score is 101. So the information is accurate. So now we can move on. And one of the most important things is also identifying relationships between variables. So maybe a quick explanation, a relationship means that one variable may change when another variable changes. For example, do students who study more hours achieve maybe a high exam rate, or does attendance affect performance? Does motivation level influence results? In all these questions, we have two entities. We have two columns being spoken to. And to investigate them, we calculate something called correlation. So we have a module called correlation in Python as well. And correlation measures how strongly two variables move together. For example, if study hours increases, the exam score will also increase. If yeah, basically that. And correlation gives us numbers between -1 and 1. So if the number is close to 1, it's a strong relationship, strong positive relationship. If it's close to 0, it's a weak or there's no relationship. And if it's -1, it's a negative relationship, meaning they don't really need each other to move. And how we do that in code is we create a variable correlation. As you can see here, the variable correlation created, and we call the module dot call. This is what calculates the correlation. So what we are comparing here is the study hours and the correlation between the study hours and the exam score. Does studying more meaning you'll get higher marks? Let's find out by printing. We run the script again, and here we can see the correlation is 0.44. It's closer to 0, meaning there's no really much relationship there. This means that students who sleep less hours still have high marks. Students who have more hours, who sleep more hours, still have high marks. So the relationship is not really strong. They do not affect each other as much because it's closer to 0. So it's a less, or rather, weak relationship. And another aspect to this is filtering data. It's quite an important one. For example, we may want to get students up who scored above 80%, or students with low attendance, or students with high motivation. So let's get the code for students who scored above 80. There we go. Top students exam score above 80. This is just a simple conditional statement which you write one liner and then you print. Obviously, to see results in Python in your terminal, you have to use this function print. And here we go. We have the students who have above 80. Of course, there's more rows below.
but here we can see 100, 89, 86, 97, 83. So it's only going to display the students who have above 80. And with that being said, once your data is cleaned, organized, analyzed, you've done what you wanted to do, we often save the process. You have to save the data sets, future work, maybe for to continue your analysis later, or use it in data visualization tools. And exporting what you have done is also just a simple function which can be obviously tailored to exactly what you want to export. In this case, I'm just going to export a simple CSV file with some columns chopped. So it's going to export simple CSV file. This is just the name of the file. I want the file to be named clean student data. And this is just going to tell me that my data has been exported successfully. It's just a message to me as a user. And me running this, it tells me my data has been exported. So you will find this file in the default Python folder here. Just open it. So you'll find this file here, clean student data. Here we go. As you can see, it was created at 1306. The time currently is 1306. And it exports my data. So you can tweak it to give you exactly what you want to see. And you can continue analysis on it later and continue using it later. And there's more to this. We visualize this data as well in charts, graphs, etc. That's a topic for another day. But just a quick sample or to show you this code here. This code you see here is for a chart. So I will run this current file and it displays a chart which I've created earlier. So it's study hours versus exam score. As you can see, exam score is 50, but this person here studied, almost 15 hours. You can see the people with the high scores studied between 15 to 25 hours up here. And, basically the graphs that visualize your data. And this is the code just for that one graph. It's not much. You can create as many charts as you want. You can also import them into your spreadsheet and export them as well. That's the nice thing. So that's pretty good. That's pretty proper. And yeah, it's not really, all this is not really just about coding, but it's just breaking your problems down into small steps, identifying patterns, applying your logic, and organizing your information so that you can solve your problems more efficiently with our machines, our systems, and all that. And that's it from me. Thank you very much. I will share the resources I've used, the code, and the data as well. Peace.